In our previous discussions, we explored the three key features of AI agents and also compared them with chatbots, AI assistants, and virtual assistants. But here is the big question: how do AI agents actually grow in capability? Just like humans develop skills in stages, AI agents also evolve through different stages of development. At the very beginning, they might just act like standalone language models, giving smart responses based on user inputs but nothing more. Then, as they stage up, they gain the ability to use tools, execute multi-step workflows, and even work in a human-in-the-loop setup, where people guide their actions. As they progress further, agents can start collaborating with other agents, learn from experience, and push towards higher stages of autonomy and intelligence. In today's video, we are going to break down these stages of AI agent development step by step, so you can better understand where AI agents are today, where the technology is headed, and what this means for the future of AI adoption. At stage 0, AI agents are large language models. That means they can understand natural language and generate text, but they cannot perform actions or interact with the external world. Think of them as highly sophisticated text processors or advanced search engines. For an example, if we will ask LLMs to write a short poem about the ocean, it will be able to write it easily. But if we will ask what's the current weather in New York right now, then it might give you some estimations, but will not be able to answer it correctly. Why it failed? Because this needs real-time data from an external API, like OpenWeather API. And these language models have a snapshot memory of the data on which they were trained. At this stage, these models do not have access to real-time information and cannot make calls to external API or integrate with external tools. Technically, Stage 0 agents rely on transformer-based architectures. They take user input, create tokens using methods like byte pair encoding or sentence piece, generate embeddings, and then perform sequence-to-sequence transformations to produce coherent responses. Some of the most commonly used models for Stage 0 agents include OpenAI GPT, LLaMA, Claude, and Mistral. These models can be accessed via APIs such as the OpenAI GPT API or Hugging Face transformers. As practical applications, Stage 0 agents can be used for chatbots on websites, content summarizers, paraphrasing tools, educational assistants for explanations and tutoring. Stage 0 AI agents excel at natural language processing, NLP, and text generation, but their capabilities are limited to tasks within their pre-trained knowledge. At stage 1, AI agents are no longer limited to just generating text. AI agent transitions from purely informational output to actionable intelligence. Agents can now integrate with external tools, APIs, and services. However, this interaction is typically single-step, meaning the agent can execute one action per interaction based on its reasoning. For example, if the user asks the LLM a question, such as, "What's the weather in New York?" Since the LLM does not have live weather data, it sends a request to an external tool, in this case a weather API. The API returns the latest weather information, which the LLM processes and sends back to the user as a clear answer. In the second example, the user asks a mathematical question like, "Calculate 25% of 480. The LLM recognizes this as a calculation task and calls an external calculator tool. The calculator returns the result, 120, and the LLM provides this back to the user in natural language. Technically, Stage 1 agents still rely on the core transformer-based LLM architecture, which performs natural language processing to understand user input, semantic parsing of user intent to figure out what the user is really asking, and text generation and reasoning to produce responses, explanations, or logical reasoning. But unlike a plain LLM, Stage 1 agents can now orchestrate external requests. That means, if the task requires live data, example weather, stock price, search, the agent calls an external API. If the task requires computation like math or code execution, It routes the request to a specialized tool, like a calculator or code runner. The external tool returns results, and the LLM integrates that into a coherent, natural language response for the user. The key enhancement is the integration with external computational resources. Stage 1 agent can formulate structured API requests, single-step API invocations for dynamic datasets, real-time queries to structured databases, execution of discrete functions exposed via REST or GraphQL endpoints, parse JSON or XML responses, and synthesize outputs into coherent natural language responses. These capabilities make Stage 1 agents suitable for real-time data augmentation, automated query processing, and task-specific API orchestration. At Stage 2, AI agents move beyond single-step interactions. They become proactive orchestrators who are capable of managing complex, multi-step workflows. These agents don't just react, they plan ahead, think through the steps, and decide which tools or APIs to use, in sequence, to achieve a specific goal. They can chain multiple tool invocations, combine reasoning and decision-making, and dynamically adapt based on intermediate results. In other words, a Stage 2 agent can coordinate multiple actions across different sources, making sure the final outcome aligns with the user's objective. For instance, when a user requests a complex goal, such as plan a weekend trip, a multi-step agent performs a series of coordinated actions. First, the agent receives the user request and understands the goal. Next, it plans the steps by breaking the goal into actionable subtasks, like booking flights, finding hotels, and suggesting activities. The agent queries external tools or APIs. It calls flight APIs to find options within the user's constraints, checks hotel availability and compares prices, and retrieves recommended activities or points of interest. After gathering all this information, the agent aggregates the results from multiple sources. Finally, it generates an output, such as a structured itinerary or a PDF summary, and returns it to the user. If any step needs refinement, like no suitable flights are found, the agent iterates and loops back to planning to adjust the plan accordingly. Notice that the agent doesn't just react to a single prompt, it strategically coordinates multiple actions to achieve the overall goal. Technically, multi-step agents rely on a combination of advanced capabilities to achieve reasoning and workflow orchestration. It begins with LLM reasoning and planning. The agent interprets the semantic meaning of a user's request and plans actions step by step. From there, it applies task decomposition, breaking down a high-level goal into smaller, more manageable subactions that can be executed in sequence. The next stage is workflow execution. The agent runs each subaction, applies conditional logic to decide the next step, and performs API orchestration to interact with external tools. Along the way, it uses state tracking to store intermediate results and dynamic context management to carry knowledge forward, ensuring every action is informed by what has already happened. Once all steps are complete, the agent enters output generation. It synthesizes the results, integrates outputs from different sources, and produces a final, user-friendly response, whether that's a structured answer, an itinerary, or even a formatted document. Together, these capabilities form the backbone of multi-step agent reasoning and workflow orchestration, enabling agents to move beyond simple responses and handle complex, multi-layered tasks. In essence, Stage 2 agents are not just reactive, they are strategic problem solvers, capable of planning, coordinating, and delivering complex tasks efficiently. These capabilities make them ideal for complex workflow automation, multi-step data analysis, and AI-assisted task planning. Stage 3 agents are collaborative systems, similar to Stage 2 agents but with human in the loop. They combine AI capabilities to perform complex, multi-step tasks, with human oversight for critical decisions or validation. This ensures accuracy and accountability and maintains a balance between automation and expert judgment. Technically, Stage 3 agents combine advanced LLM reasoning, multi-step workflow orchestration, and human feedback mechanisms. The AI can generate outputs, suggest solutions, or take actions, but it pauses at key checkpoints for human validation. For example, in AI-assisted code generation, the developer asks the AI agent for help. The AI agent suggests possible solutions, such as algorithm optimizations, function generation, or refactoring strategies. The developer reviews these suggestions, ensuring they are correct and fit the project's requirements. Only after human validation are the suggestions accepted and finalized. This workflow ensures accuracy, accountability, and a balance between AI automation and human expertise. In high-stakes domains like healthcare, Stage 3 AI agents support doctors but do not replace them. The doctor provides patient data to the AI agent. The Stage 3 AI agent analyzes the data, leveraging medical knowledge and external tools, like lab reports or imaging systems. The agent then suggests possible diagnosis or treatment options. A doctor reviews these suggestions, applies medical expertise, and makes the final decision. This human-in-the-loop process ensures that the AI accelerates analysis, but critical decisions remain in human hands. This balances automation efficiency with expert oversight, maintaining reliability, compliance, and patient safety. Finally, Stage 3 agents work like Stage 2 agents but add a human in the loop. The key benefit of Stage 3 agents is they reduce errors and ensure that high-stakes decisions remain under human control. At Stage 4, AI goes beyond using just one agent. Now multiple specialized agents work together. They can communicate, delegate tasks, and coordinate actions toward the same goal. This setup makes the system more powerful because it can work on tasks in parallel, use specialized knowledge from different agents, combine results to reach the goal faster and more accurately than a single agent could. Let's look at a real-world example of a Stage 4 multi-agent system. Imagine an AI-powered startup. One agent analyzes market trends. Another agent creates marketing content. Another answers customer queries. And another monitors financial performance. Individually, each agent is specialized in their specific domain. But together, they operate as a coordinated team and share information. This helps to complete projects faster and more efficiently than a single agent. Technically, at Stage 4, AI agents basically start acting like a well-coordinated team. First, they can talk to each other in real time, which means every agent knows what the others are doing, so there are no surprises and no duplicated work. Next, they're smart about dividing the work. They can take a big, complex task, break it into smaller parts, and assign each part to the right agent. They also stay in sync with each other. Thanks to autonomous coordination, all the agents make sure their actions are aligned, keeping the workflow smooth and efficient. Another important thing is sharing a common understanding. With distributed state management, every agent sees the same overall picture and can track progress along the way. And of course, sometimes conflicts happen, like if two agents try to do the same thing. But Stage 4 agents have conflict resolution strategies to handle this automatically without slowing anything down. So when you put all this together, Stage 4 agents can work as a team to handle big, complex tasks quickly and accurately, almost like a group of experts who always know what the others are doing. At Stage 5, AI agents move beyond being just smart assistants. They step into true autonomy and adaptability. What does that mean? They're not just following instructions, but they're learning from experience. Every success or mistake becomes a training data. They refine strategies over time, just like a human professional who improves with practice. They optimize workflows automatically, based on constant feedback mechanism, spotting inefficiencies and making processes smoother without needing human supervision. In other words, these are self-learning, self-improving agents that evolve continuously, becoming more capable the more they work. Think of Stage 5 AI agents as colleagues who get better with every project. They don't repeat what you tell them, but they learn from experience and continuously improve. Let's understand this with an example of a project management using AI. Imagine you're running agile sprints. Normally, you will track tasks, find delays, and adjust future plans manually. But with a Stage 5 project management using AI, it tracks task completion across your team in real time. It spots bottlenecks, like a task that's blocking others or a developer consistently overloaded. Next sprint, it automatically adjusts the plan by balancing workloads, optimizing timelines, and even recommending who should take what task. Over time, this agent doesn't just help, but it becomes your intelligent Scrum Master. Now let's take another example of stock trading using AI. It looks back at your past trades, analyzing patterns of profit and loss. It analyzes stock price movements, market trends, and multiple other data points. It refines strategies, for example, adjusting how much risk to take in volatile markets. Over time, it maximizes return on investment by continuously adapting to market shifts faster than a human could. In other words, the more it trades, the smarter and more profitable it becomes. These examples highlight the essence of Stage 5, self-learning, self-improving agents that get better every cycle. Technically, Stage 5 agents use some really advanced mechanisms to learn and improve over time. First is learning by trial and error. They use reinforcement learning tools like RLlib, Stable Baselines 3, or OpenAI Gym. Basically, the AI tries different actions, sees what works, and gradually figures out the best way to make decisions. Next, they have memory and using experience capabilities. Stage 5 agents have feedback loops with memory systems like LangChain combined with vector databases. What that means is they store what happened before, recall it later, and learn from past experiences. Then they have performance tracking mechanism. They use logging and analytics tools to see what's working and what isn't. By keeping track of successes and failures, they can figure out exactly where they need to improve. All of this happens in continuous learning loops. They try, learn, adjust, and repeat over and over, getting better each time. And when you have multiple AI agents working together, they don't just improve themselves, they improve the efficiency of the whole system. At this stage, AI agents are truly autonomous, adaptive, and evolving. They combine continuous learning, dynamic strategy optimization, and self-improvement, making them capable of handling complex, dynamic environments with minimal human intervention. So there you have it, the 6 stages of AI agent development. From simple text responders at stage 0, all the way to self-learning, fully autonomous systems at stage 5. And we've explored the tools, frameworks, and capabilities that make each stage possible today. Understanding these stages doesn't just show us where we are now. It also highlights the incredible potential of AI to transform businesses, industries, and everyday life. If you found this video helpful, make sure to like, subscribe, and hit the bell icon for more tech insights. And comment below, which stage of AI agents do you think is already part of your daily life, and which one excites you the most?